don't be. No reason to be scared. I'm not scary, usually. Okay, all right, take a look up here. This is what we left off talking about last, all right? Gentlemen. Isaac. Great. Here we go. We started. We're going. Exactly. All right, so where we left off last, I told you that we were going to take a couple of classes to review systems of equations, right? Systems of equations are when we consider two or more equations at the same time. We talked about some different types of systems of equations that I gave you here. And then when we classified them, right, we had our independent consistent. These were our one solution or two, like 1 point of intersection. Right, then we had our independent inconsistent where there was no points of intersection, and then we had our dependent consistent where every point of intersection was the same. And so then in the last lesson, we talked about how to find those intersection points with two of the three methods that we learned in Algebra 1 for solving systems of equations. We can either draw a picture, we can graph them, and we can look for where are those intersection points. So we did that one. And then we did substitution, where we took one equation and we solved it down to one variable, and then we plugged it back into the other equation so that we had a one variable equation. We figured out whatever the value of that variable was, and then we plugged that back in and then came up with the other one, right? Okay, so those are the two methods we use. So today we're going to review the third method, which is the elimination method. And so we're going to dig into that, and we're also going to do some application, yes, that means word problems, with the elimination model. All right, so with that being said, as sort of an introduction, we don't have any really more notes to take. We're just going to jump in and start doing the math together. So formative main page, please. Here we go. All right, so you should be looking at this lesson title. Is everybody there? Yes, everybody's there. Yes, everybody's there. All right. What's that? Let's get this going. Here we go. All right. So here's the deal. There are a few different types of elimination questions that you're going to see. And so we're going to work through 4 different types that you're going to see. All right. Now, for the elimination question, let's keep something in mind. The way this works is we're really trying to create a big addition problem. So let's go in the show your work section and sort of just draw a sum bar down here and a plus sign. And so the idea is that we want to take our variables and line them up in columns with matching variables. And then we're going to create a sum problem where we're just going to add the columns straight down. Now the goal is to, with elimination, to eliminate one of the variables, which means that you got to have an equation where one of the variables has opposite terms on it. So this is the first example of a very easy question because it's already set up with opposite terms on the y variable, right? You can see that I've got positive 2y and negative 2y. And so if I just add that straight down, that's going to give me 0 y's. And so this is going to cancel out essentially. And then I'm just going to work my way down. So I'm going to add my 3x's and my 5x's. That's going to give me 8x on one side of my equal sign. On the other side, I'm going to get 64. And so then I'm going to get my x value is 8. Right, now keep in mind, this is the x coordinate of our, well, and now it's going to be a solution, right? We know that because we have an x coordinate. If it were no solution or infinite solutions, our variables would have completely eliminated. So we know this is going to be independent, consistent. And so then I'm just going to use that, and I'm going to go back and I'll plug it into one of my other 2 equations, and it doesn't matter which one. I'll do the first one. So it's going to be 24 plus 2y is equal to 22. Subtract 24 from both sides. I get 2y is equal to negative 2. I divide by 2, and I get y is equal to negative 1. Right? Yeah? No? Yes? No? Yes? Maybe? Good? Okay. All right. And so then when you go to type your answer in, then you're going to put in your parentheses and you're going to go 8, and then you're going to do a comma, and then you're going to do a -1, and then you should be able to get a point on formative. I got a point on formative. Woo! Yeah, that's fine. All right, elimination number 1, the easy way. Everybody good? All right. Okay, let's go then to... So here is elimination number 2. Okay, so again, it's going to be coming down to like looking for certain context clues. So in this case, you can see that, well, I've got my variables are lined up. That's nice and neat already for me, so that makes things easy. And I've got x, 1x, and I've got 1x. But I don't want them to be the same. I want them to be opposites. So the easiest way to create opposites is to multiply by -1 in this case. And so what I'm going to do is I'm going to take both sides of my equation, and I'm going to multiply through by -1. And then I'm going to rewrite my system of equations. So then I'm going to have x plus 7y is equal to 17. And then I'm going to multiply through by -1. So then I'm going to get -x plus y is equal to +7. And then once I have that set, then I can do my sum bar, because my x terms are going to cancel out here. That's going to leave me with 8y is equal to 24. And then y is equal to 3. And then you can use any one of these to go back and then figure out your value. So let's do the first one. So then x plus 7 times y is equal to 17. So x plus 21 is equal to 17. X is equal to, subtract that off, and I get -4. And again, because I got answers, because my variables didn't eliminate, then I know that I have an independent, consistent system with one solution. These are, of course, linear functions. We learned that the variable to the first power, the input to the first power, makes them linear functions. We learned that back at the beginning of the school year. All right, so in this case, I'm going to go -4, and then a comma, and then +3, and woo, I got another point on formative. Yay for me. All right, awesome. So you're either going to just be right set up to do elimination, or maybe it's going to be really simple. All I have to do is multiply through by -1 on one of the equations. All right? Good so far? All right. Okay, next up. All right, so I look at my x's and my y's. Everything's lined up. I don't have opposites, so the easy one doesn't apply. I don't have sames, so the whole just multiplying through by -1 doesn't apply. So then in this case, I'm going to have to manipulate my equations some way in order to create these opposites. Now, I usually start with the smaller number, and I ask myself, can I turn the smaller number into the bigger number using multiplication? I don't want to deal with fractions in that part of it. So in this case, can I multiply 2 by something and get 7? Or can I multiply 3 by something and get 6? Okay, the 3 obviously is the easy one, right? Okay, so if I multiply 3 by 2, I'm going to get 6, right? But I don't want -6y and -6y. I want -6y and +6y. So what do I have to multiply by? I have to multiply by -2, right? So good. So I'm going to parenthesis off my equation. I'm going to multiply everybody through by -2, give myself a squiggle, and then I'm going to rewrite my system of equations. 7x minus 6y is equal to -53. And then I'm going to have -4x plus 6y is equal to +26. All right, now that I have my system of equations set up for elimination, I can just multiply or add straight down. So my y variables are going to cancel. That's going to leave me with 3x is equal to negative 27. And then divide by 3, and I'm going to get x is equal to negative 9. Okay. Now look, you guys are honor students. This shouldn't be super complicated. This is Algebra 1 skills. We've done this before. I'm going to tell you right now where you're going to make your mistake. Sign errors, sign errors, sign errors. If you don't pay attention to the signs, things are going to get ugly, okay? And just because the answers are ugly doesn't mean that they're wrong. Like, okay, let's take, for example, this negative 9. Oops, I don't want to do that. So let's take this negative 9. I'm going to go back. I'm going to use the second one. So I'm going to go 2 times negative 9 minus 3y is equal to negative 13. Okay, so that's negative 18 minus 3y is equal to negative 13. I'm going to add 18 to both sides. So I'm going to get negative 3y is equal to, what's that, positive 5? Yeah. Divide off negative 3. Did I do my math right? Yeah. Yeah, I did do my math right, huh? So what's y equal to? Negative 5/3. This is the point where students start coming up to my desk and go, Mr. Vargas, I didn't get a whole number. The answer must be wrong. No, it's not wrong. That actually is the answer. Unless I put it in the format wrong. But, you know, so let's see. I might have put the 5/3 wrong. Hang on. Let's see. Because I think I remember typing this one in. No, I can't do it that way. All right, I got to get my actual keyboard. Hang on. Okay, stand by. Okay, there we go. So, yes, it is possible to get fractions. It is possible to get decimals. So, again, if you're dealing with a fraction or a decimal, whatever the problem starts in, keep it in. Whatever it ends in, keep it in. But for repeating ones like this, I want you to write it as a fraction. If it terminates, you can put it as a fraction or a decimal. It doesn't really matter. All right. So that's changing one equation to do our elimination. All right, let's look at the last one. Okay. All right, so with number 4, we're not set up, right, just to jump right into it. Multiplying by negative 1 isn't going to help us. Can I multiply 2 and change it into a 5? Not easily. 3 into a 7? Not easily. So in this case, I've got to multiply both equations. So now what I'm looking for is the least common multiple. So let's talk about 2 and 5. What's the smallest number that we could turn both 2 and 5 into with multiplication? 10. All right, now let's talk about 3 and 7. What's the smallest number that we could turn 3 and 7 into? 21, right? Okay, so should we use 10 or 21? Which one? 10. I'm going to use 10. I'm going to try to use the smallest number, okay? You want to use 21? Go for it. I don't really care. You're still going to get the same answer, but again, make your math easier on yourself if possible. Now, one of them is, if I'm going to do the 10, one of them is going to have to be negative though, right? Because I got to make sure that I got a positive 10x and a negative 10x. So I'll just do the top one, negative. And again, it doesn't matter which one you do. So in this case, I'm going to multiply by negative 2 on the top. And I'm going to multiply by 5 on the bottom. Now listen. Okay, look. I'm modeling good work for you. This is what I'm going to expect from you. Showing me how you're manipulating these and then rewriting your system of equations. Oh, sorry. Right? So for each of these questions, go back and look at the work that I modeled for you because this is what I'm going to want it to look like. So once you've shown me what you're doing to change the equations, then you rewrite. So this is going to be negative 10x minus 6y is equal to positive 14. And then I'm going to have positive 10x plus 35y is equal to 15. And then I can do my sum bar. 10x's cancel out. So I got positive 35 and negative 6. That's positive 29. 29y is equal to, oh, that's good, 29. Oh, that's nice, huh?
Period.
Divide by 29 and we get uno. Y is equal to 1. Oh, yeah, that's the other place you're going to make your mistake. Don't forget which variable you're solving for. Put it in the right place when you're writing your ordered pair. This is y. And so then I'm just going to go back and use one of the other ones. I'll use 2x plus 7 times 1 is equal to 3. So then that's 2x plus 7 equals 3. 2x equals negative 4. X equals negative 2. All right, and then put my answer into formative like this. Negative 2, 1. And woohoo! I got a point. Did you get a point? You guys have 4 out of 4 now? Right. 4 out of 4. 4 out the 4. All right, so listen, I showed you 4 different types. The easiest type, number 1, it's already set up for elimination. Number 2, all you got to do is multiply through by negative 1. That's really simple. Number 3, you only have to change one of the equations. Number 4, you got to change both of the equations. Okay? Make your life easy. Look for the easiest possible way to do these problems. All right, any questions so far? Everybody good? Okay. All right. So I'm in the show your work section here. It looks like Marcy bought a total of 20 used books and CDs during a yard sale for a total of $54.50. If the books cost $1.50 each and the CDs cost $5 each, how many of each did she buy? And we're supposed to solve this using a system of equations. All right. So step number 1, easiest thing to do. Let's define the variables we're going to use. We're going to do a system of equations, right? We're working in 2 variables right now, so that means there's going to be 2 things that we're going to represent with our variables. Now, we're looking for how many of each book and CD that she purchased. What do you think we should use for variables? How about B and C for book and CD? That sounds pretty good, right? All right, so let's define our variables first. So we're just going to come over here to the side and we're going to say B equals books. And then I want you to put in parentheses amount. Okay, right? Because this is a number of books. And then C, we're going to put over here CDs. And again, this is an amount. Just to keep that in mind. So we're talking about a number of CDs. Now we got to come up with 2 equations here. And we're given some information. So why don't you take a second and talk it over with a neighbor. And let's see if you can come up with one and or both equations that you would need for this situation. Go ahead, give it a talk. Give it a little talky talk talk. Talk it over. So who wants to help me out? Who's got an equation that they think we can use to begin to figure out a system of equations to find books and CD costs? Who's got one to offer up? No volunteers? All right, Anthony, what do you got? 1.50 B plus, what'd you say? 5C? 5C, yeah. 5C equals what? 54.50. Okay, so this is the money equation, right? And that would make sense, right? Because if you bought one book, it would be $1.50. If you bought 2 CDs, it'd be $10, right? And so then we're looking for some combination of B's and C's that's going to get us to $54.50. But there's a lot of combinations of B's and C's that'll get us there, right? So the thing is we need something else to bound that. Who's got another equation to help us? Anybody else come up with a second one? Andrew? Okay, yeah, that would make sense, right? Like the total number of books, B plus C, is 20. Okay, yeah, cool. Right on. Well, hey, you have a system of equations, and we just did 4 solving problems, so good luck. Go. Did you get here? Yeah. So again, you could have done this in a couple of different ways, right? I'm not specifically telling you have to do this in one way or the other, but I chose to use elimination because that's what we're practicing in this lesson. Might have been a choice of yours to do substitution. You could do that as well. So again, I'm looking for clearly communicated work that shows the answer. Now, one thing I do want to make sure to emphasize is, even though the math problem is really simple, I got 13 books. It's really obvious that the number of CDs is 7. You still got to show the work for that. You still got to show me how that 13 books translates into your equations to come up with the 7, okay? So make sure that you don't leave off the work just because the math seems easy to you, okay? Make sense? All right, good. All right, let's try another one then. Again, we're solving this with a system of equations. So we have Landon babysits and works part-time at the water park over the summer. 1 week he babysat for 3 hours, worked at the water park for 10 hours, made $109. The next week he babysat for 8 hours, worked at the water park for 12 hours, made $177. And we're looking for how much money does Landon make per hour at each job? Okay, so this is not a number of hours. This is not an amount. This is more like a value, huh? Like a dollar amount answer. Okay, so let's define some variables. What do you think would be good variables to use here? How about B and W for babysitting and water park? That sounds pretty good. All right, so then let's define our variables. So we're going to go B is going to be babysit. And here, let's do this. We'll put in parentheses slash dollar slash hour so we know that we're looking for a value amount. So like in the last question, we had a value like a cost amount. We knew that the costs were the coefficients, like $1.50 and $5, right? Okay, this is again another dollar amount. All right, well, you got some situations there. We're looking for a situation or a system of equations. It's going to model this. Let's see what you come up with. Give it a shot. All right. I heard a chorus of yeses from Sophia's direction. Sophia, you got one for me? So 3B, which would be 3 hours babysitting plus 10W. 10 hours at the water park equals $109. Sure, that would make sense. Well, that's pretty easy, huh? What would be another one then? Sure, that sounds good. 8B plus 12W equals 177. So see, we have 2 statements that connect babysitting and water park cost rates. And because we have those 2 statements, we can now use that to narrow in on a solution for B and W. All right, now I want you to catch something. Hang on, listen, Algebra 2 honor students, okay? 1 variable, 1 solution. 2 variables, how many solutions do we have? 2. What do you think we're going to have if we had 3 variables? 3 solutions? I don't know, maybe we might see something like that. You never know. Okay, go ahead, do this one. Let's see what you got. That's the Algebra 2 part. Okay, here we go. Excuse me. So let me clear my throat. Did you get here? Yeah. All right. Me too. All right, good. Yay. Exciting for both of us. That's good news. Okay, so again, it has to do with defining your variables to start off with, and then setting up your equations. Take the time to write out what your variables mean. That way you don't forget, okay? You can use X's and Y's if you want. That's fine. Whatever you're comfortable with, but give yourself some meaning to it because these are context stories, all right? Okay, I got one more that we're going to do together here in class.
I was just going to say that.
All right. Here we go. All right, so this time, let's see. We're solving this with a system of equations. Show work to support our answers. Kent has a collection of pennies and nickels with a value of $1.98. The number of pennies he has is 5 less than twice the number of nickels. How many of each coin does Kent have? Well, we got to do a system of equations, right? We're looking for some nickels and some dimes. What do you think some good variables to use would be? Okay, all right. Let's use our pennies and nickels. Sorry. So yeah, so we'll go P. This is the number of pennies, right? Pennies. So this is an amount. What's that? I might ask you to define your variables, like if I do as a question, but if not, I still would recommend you do it because it'll help you keep track of things. Okay. So just train yourself to do it and you're good. All right, so here we go. We got the number of pennies, the number of nickels. Yeah, well, go ahead. Why don't you see what you come up with? Why don't you put some equations together and then we can talk about it. And I'll give you, a minute? Minute and a half? 2 minutes maybe? We'll see. See what you come up with. Let's talk it through a bit. Okay. Any thoughts on some things that we could put up here in terms of equations? P equals 2n minus 5. Oh, that's 5 less than twice the number of nickels. That's an equation. That connects a P and an N together. I'm down with that. Okay. All right. Equals N equals 1.90. P plus N equals 1.98. Okay, the only problem with that is that P and N are like amounts, right? The number of pennies, the number of nickels, but the answer is money. I thought it was like the $5. 5N? What would be 5N? So 5N like that? What's that? That would make sense, right? Because it'd be the number of nickels times every value of a nickel, right? Okay, all right. Let me make a little room in there for that. I like that. I like that, Isaac. So you said 0.05N like that? Like that's the value of a nickel? What would we use for the penny one then? All right, 0.01 P. Okay, so if I had 1 penny, I'd have 1 cent. If I had 5 pennies, I'd have 5 cents. If I had 5 nickels, I'd have 25 cents. Yeah. Okay, that works. So some combination of pennies and nickels has to add up to $1.98. Okay. So Simone, yes, you could have done 5N and 198. But actually, that really comes more in the changing of the equations. This is really more the setup, because this would connect it to the money. So it's like writing Pythagorean theorem as a subtraction problem. You see what I'm saying? It's like you want to write it as an addition problem first, and then the subtraction comes in the solving. Huh? It's up to you how you do it. No, you don't have to use elimination. No, I don't. No, I never said anywhere in the question for these. So if I don't specify what you have to do, then you're free to use whatever skill you think is easiest or best for you. If you want, you can use substitution. I mean, sure, why not? All right, did you guys get here? 29 nickels, 53 pennies, right? All right, now, it's great when formative confirms for you that you have those points, but on test day, since you weren't crying because you were like, I know how to do this, right? Yeah. How would you check it? Well, then you would just add it up, right? 53 pennies is how much money? 53 cents, right? Okay, you got 29 nickels. You should know that 20 nickels is $1. Okay, so that's $1.53, right? And then you got 9 more nickels, which is 45 cents. What's $1.53? Yeah, you can plug them back in too. Exactly. All right, so you're reasoning through those. All right, good. So you've got a variety, I'll say, of tools you can use when it comes to the word problems. So do watch the instructions of the question. If I specify that you have to use a particular method, then you got to use that method. But if not, you're free to use whatever method you want. Again, I would recommend choosing like the easiest method for you. That's great. But again, I did this with substitution. But again, you could do it with elimination. And so, yeah. All right. Got it? All right, good. Look, you guys are going to have a little time to get started on your homework. Good for you. All right.